Welcome to this explainer. So I want you to think about the absolute last thing you threw away. You got it? Now multiply that by 10 billion. Yeah, it's a completely mind-boggling number. Today, we're exploring how China is tackling an unprecedented waste challenge by building a massive industrial-scale urban mine. We're talking about a system designed to process just unimaginable amounts of material every single day, quite literally turning what we casually call trash into highly lucrative resources.
To really wrap our heads around this massive shift, we're going to unpack 6 key areas today. First, the 10 billion ton challenge. Then, extracting gold from e-waste, recovering solar panel silicon, transforming debris in textiles, circular economy processing techniques, and finally, overcoming regional market challenges.
All right, let's jump right into Section 1, the 10 billion ton challenge.
Okay, let's start by establishing the sheer, staggering volume of material we are talking about here. 10 billion. That is the number of tons of brand new solid waste that China generates every single year. Just let that sink in for a second. To put that into context, historically, the country was looking at a backlog of up to 70 billion tons of waste. It was so bad that local officials actually coined the term garbage sieges because major cities were quite literally surrounded by dump sites.
So how do you even begin to handle that? Well, the government kicked off a waste-free cities program. Look at Hangzhou, for instance. This city has 12.6 million residents, and it actually just got recognized as one of the UN's top 20 zero-waste cities worldwide. Imagine if every single trash can in your neighborhood was digitally connected. That's exactly what they're doing. They're tracking thousands of collection points in real time to automate the sorting and disposal process. They even have these specialized facilities processing 4,000 tons of municipal sludge every single day. It's basically setting a high-tech digital baseline for how megacities can dig their way out of this crisis.
Which brings us to Section 2, extracting gold from e-waste.
Now, over in specialized processing parks, your old electronic waste isn't just getting tossed in a landfill. It's entering a highly efficient, closed-loop system. Look, e-waste is one of the fastest-growing waste streams on the planet, right? In China alone, the number of discarded devices broken down through proper, standardized channels has skyrocketed, from 10 million in 2012 to nearly 100 million a year today. So instead of a straight line to the dump, stuff like old washing machines, TVs, and computers are routed into a cyclical system that aggressively recovers materials like copper, silver, and plastics.
But here's where it gets really sci-fi. Forget using toxic cyanide or extreme heat. The real breakthrough here is speed. Scientists recently came up with a non-toxic chemical wash that happens entirely at room temperature. In under 20 minutes, less time than it takes to watch a sitcom, this process dissolves and pulls precious metals right off old computer chips in motherboards. We're talking a staggering 98.2% efficiency for gold extraction, plus a 93.4% recovery rate for palladium. That is absolutely wild. So why is this such a game changer? Well, it all comes down to pure economics. By pulling 1.4 grams of gold from just 10 kilograms of old circuit boards for around $72, this method drops the extraction cost to roughly $1,455 per ounce. Now, when you consider that virgin mined gold can easily hover well over $4,000 an ounce, suddenly that old laptop sitting in your closet is literally a gold mine. It takes urban e-waste mining from a cool concept to a highly lucrative, scalable business. All right, let's move on to Section 3, recovering solar panel silicon.
This brings us to a really fascinating green tech paradox. Solar panels are obviously amazing for clean energy, but once they hit the end of their 20 to 30-year lifespan, they turn into a monumental waste problem. China is a global leader in solar, which means they are staring down the barrel of an estimated 1.5 million tons of discarded panels by 2030. And get this, that number is projected to surge to an unbelievable 20 million tons by 2050.
So, what's the fix? You see, a solar panel isn't just one thing. It's glass, silicon, and metal all tightly glued together by this ridiculously stubborn polymer called EVA adhesive. You absolutely cannot just smash it with a hammer. Instead, they use these specialized dismantling lines. First, automatic cutters strip away the aluminum. Then the panels get crushed and undergo precise thermal treatment. By baking them at 500 degrees Celsius for 30 minutes, 99% of that stubborn adhesive literally just melts away. After that, vibrating screens and magnets do their thing to separate the materials, refining the silicon to such a high purity that it can actually be fed straight back into making brand new solar panels.
Moving right along to Section 4, transforming debris and textiles.
Let's zoom back out from the micro level of silicon and gold. This network also heavily targets massive bulk materials. Just to give you an idea, in 2023 alone, China generated 2.41 billion tons of construction waste. Instead of hauling all that concrete to a landfill, picture this: massive mobile crushers rolling right up to demolition sites, just chewing through 300 tons of rubble an hour. They instantly churn that debris into brand new building materials right there on the spot. Last year, this approach kept over 860 million tons of material actively in the economic loop.
And we're seeing a very similar push in the textile industry, too. Right now, China produces about 22 million tons of textile waste every year, but the recycling rate is hovering around 20%. They've got aggressive national targets to bump this up. The goal is to hit 25% very soon and then 30% by 2030. How? By feeding tons of discarded clothing through automated carding machines. These machines clean, untangle, and respin old fibers into brand new yarn. The ultimate goal is to churn out 3 million tons of recycled fiber every single year by the end of the decade.
Next up is Section 5, Circular Economy Processing Techniques. Underpinning all of these operations, from old cell phones to discarded sweaters, are some seriously foundational scientific processes. One major technique is anaerobic digestion. This is how the network handles rivers of municipal organic waste. Instead of just letting food scraps and used cooking oil rot in a landfill and release methane, this process uses microorganisms in a completely oxygen-free environment to break it all down. The end result? It generates renewable biogas and fuels that are fed straight back into the power grid.
Another core technique is thermal treatment, which is basically the backbone of waste-to-energy plants. By utilizing extreme heat, we're talking up to 1,500 degrees Celsius, thermal treatment does it all. It melts glass for new bottles. It completely incinerates highly hazardous medical waste safely. And the best part? The heat generated during all of this is captured and pumped right back into the electrical grid. So it's double duty, safe disposal, and energy generation in one swoop.
Finally, let's turn to Section 6, Overcoming Regional Market Challenges. Now, you might be thinking, executing a strategy this complex across a massive nation has to come with some serious friction, right? Absolutely. The biggest hurdle is the infrastructure divide. On one side, you have Tier 1 megacities and coastal provinces like Guangdong and Jiangsu. They have these highly automated, AI-driven eco-parks that handle waste with laser precision. But on the flip side, suburban and rural districts often suffer from a huge lack of modern recycling infrastructure. They still rely heavily on manual collection and informal waste handlers, which creates pretty massive bottlenecks in the supply chain. And then there's the money side of it. The economics of recycling can be surprisingly fragile. Recyclers face really volatile market prices for raw materials. If commodity prices drop, their profitability can literally vanish overnight. There's also an issue with a lack of unified national standards. Sometimes it genuinely costs more to produce recycled materials than it does to just mine virgin resources. To combat this, the government is leaning hard into Extended Producer Responsibility, or EPR, mandates. This basically forces manufacturers to pay for the collection and recycling of their products at the end of their life cycle. It shifts the burden off of local towns and puts it right back onto the producers. Imagine if the company that built your phone had to pay to recycle it when you're done with it. That is EPR in action.
So as we watch this massive industrial experiment unfold, from digital waste tracking in Hangzhou to 20-minute gold extraction in high-tech labs, it really forces us to look hard at our own global supply chains. As the tech gets better and the costs drop, it leaves us with a truly fascinating question. Will the future of the global economy depend not on mining the earth, but on mining our own trash? Thanks so much for joining me on this explainer, and I will see you next time.